Good afternoon, everyone. Welcome to the class of antenna and wave propagation. The subject code is KEC 603, and today we will discuss about the topic of the topic of the related to the vector calculus. I'm I'm Mr. Himanshu Nagpal, assistant professor in EC department of AKGEC Ghaziabad. First, before starting with the vector calculus, we'll just discuss about the coordinate surfaces, and in the coordinate surfaces we have studied that we know that there are three types of coordinate systems. First one is the rectangular coordinate system. That is also known as the Cartesian coordinate system. Second one is the cylindrical coordinate system. And third one is the spherical coordinate system. Clear? So first we'll discuss about the, if I say first we'll talk about the rectangular coordinate system. In the rectangular coordinate system, let's say this one is the rectangular coordinate system. This one is x, y, and this one is z. Let's say if I say case 1, or you can say if I say x is constant and y and z are variables, then let's say if x is constant, means this x value is constant, y and z is the variable. So you will get what? You will get the, let's say if I say x equal to 5, y and z are the variables, means at x equal to 5, let's say this one is 5, at x equal to 5 there will be a surface which is in the plane of yz. This may be the surface at x equal to 5, y equal to z, or you can say that yz plane will be there, and in that case yz plane will be there, and in that case there will be a area of that surface will be equal to what? Y multiply में z. And if I talk about the area of surface, if I talk about the surface vector, then surface vector will be perpendicular to the plane of surface. Means you can say the surface vector S vector will be perpendicular to the plane of surface, that is S vector is equal to y multiply with z, and its unit vector will be in the direction of plus, or you can say minus, in the direction of a cap x. Means x vector will be in the direction in the inside the screen or outside the screen. Depends that the unit vector during the calculation of unit vector direction, in the calculation of S vector, that the direction of unit vector should not be inside the volume. Okay, so clear? Now let's say if I say Now for the next case, if z is constant, x and y are the variables, then this type of surface will be formed. Z is constant, and surface will be in the form of xy plane. In that type, the surface area will be x multiplied by y, and direction unit vector will be in this direction, in the plus a cap or minus a cap. But that direction unit vector depends that whether it encloses the volume, and the direction unit vector should be outside the volume, not inside the volume. Similarly, if I say y is constant, x and z are the variables, then you can say that y is constant, x is, then you can say that this surface, this green color surface will be formed. Means if I say this one is the wall, then this side of wall represents the surface area or surface plane surface area. Clear? Now similarly for the orthogonal coordinate system, in case of for the cylindrical coordinate system, we will discuss about the case when two variables are given, when in cylindrical coordinate system is rho, phi, z, when one coordinate point is constant and other two coordinate points are variable. So there will be three cases. Case 1, when rho and z are the variables and phi is constant. Second case, when z is constant, variable is rho and phi. And the third case, when rho is constant, phi and z are the variables. So for the case 1, if phi is constant, if I say phi is constant and rho and z are the variables, then this type of surface will be formed like this one. This one means this blue one. Clear? And if I say this is the surface, then you can say what? Surface area will be, you can calculate, but the direction of unit vector will be what? Will be perpendicular to this plane, means this one or this one. You can say then in that case, unit vector will be what? A cap phi, and this a cap phi can be plus or minus, that depends whether unit vector encloses the volume or not. Now the case 2, for the case 2, let's say z is constant. If z is constant, rho and phi are the variables, so you will get what? This plane surface area. This one. Clear? In that case, what? Height is constant, means z value is constant, and phi and what? Rho is the variables, means this one. This phi and z and rho is variable. This phi and z, sorry, phi and let's say this phi is constant, sorry, this z is constant and phi and the rho is the variable. Something this part type of part will be there. This one, this surface area will be there. Clear? Now for the third case, is when rho is constant, and the phi and z is the variables. When rho is constant means this radius is constant and phi and z are the variables. So you will get what? This type of figure. Cylindrical of fixed radius. Clear? In that case, unit vector will be in the direction of what? A cap rho, whether in this direction. Clear? Or this can be plus minus A cap z. Now next one is the constant coordinate surfaces for the spherical system. In same here, let's say there are three coordinate system r, theta and phi. Case 1, variables and constant, and this is only the scalar quantity, so there will be a no unit vector. Case 1, when theta is constant and variable will be what? Phi and r. Second case, when phi is constant, r and theta is the variable. Third case, when r is constant, theta and phi is the variable. So we will see here that if I say first one is the theta is constant. When I say theta is constant means this is constant value. So you will get this shape will be there. This one is the surface area. Clear? Now if I say phi is constant, you will see here that the phi is constant. Sorry, unit vector will be there, no? As I can say that this is a surface vector, surface area. So unit vector will be in the what? In the A cap theta. Third one is the second case, when phi is constant means this phi is constant, this value is constant, and theta and this r is variable. So you will get what? Unit vector, this one, phi is constant, this surface area will be formed, this green one. So you will get in the direction of A cap phi plus minus. Clear? R is what? R is what? R will be, when R is constant, you will get a ball with a constant value with a constant radius, fixed radius. In that case, you will get what? A cap R, and that will be not in the negative, only in the positive, that is plus A cap R. So when R is constant, it is a sphere with its center at the origin. When theta is constant, is a circular cone will be formed with z axis, and when phi is constant, the semi-infinite plane will be formed in the cylindrical system. Now with starting of vector calculus, we will deal with the surface vector, differential length, we will deal with the mainly with the surface vector. Clear? Now, one of the topic of the vector calculus, or starting topic of the vector calculus, is the differential elements. Differential element, there are three components in the there are three types of differential three components in the differential element is the differential length, differential area, and the differential volume, and these all are each in what? Rectangular coordinate system. Differential length, differential area, and differential volume will be there. For the cylindrical coordinate system, these three will be involved, and for the spherical coordinate system, these three will also be involved. Similarly, this one is differential elements, another one is the integral. You will see in the vector, you will see that is the line integral, surface integral, and the volume integral. So today we will discuss only about the differential element and one of the numerical related to the differential element. Now let us say for the rectangular coordinate system, if I say let us say this is a point P which having coordinate system x, y, and z, and this A vector is ax a cap x प्लस में ay a cap z a cap y प्लस में az a cap z. So what is ax? Ax will be in this direction, ax, and what is this ay? If I take the transformation in this area, so this one is the, you can say this one is the ay in the direction of a cap y, clear, and this one is the az in the direction of a cap z. Now for taking the differential elements, means very small unit of this point source will be considered. Now if I say if all these are the variables, then the cuboid will be formed, clear. Now if I say this point P as a differential element or differential volume or differential cuboid, then small area will also be, small volume will also be formed, clear. Small cuboid will be formed at this point P. So the dimensions of this point P, this cuboid will be what? Dx, dy, and dz. As we know that the cuboid is a 3D figure in which you can say three parameters, you know, length, breadth, and height, clearly. So length, if I say length is the this direction, means the x, y is the breadth, and height is the z. So you can say this one x, y, and z. So differential point, if I consider this point P as a differential volume or differential point, clear. So small cuboid will also be formed when all these are the variables, means dx, dy, and dz, or you can say there will be three dimensions dx, dy, and dz. Or you can say also say that if I take this smaller unit vector dA or d length, differential length, that is dl, this dl will also be equal to what? This dl, this is dl, this will be equal to what? P x y z. This will be equal to what? dx length, dy, and you can say dz. So dl will be equal to what? Differential length. This differential length will be equal to what? dx a cap x plus में dy a cap y plus में dz a cap z. Clear? Now next one is the differential surface. As I already told you, surface area or surface plane will be formed when what? When there are two variables and one coordinate system, one coordinate point. Is constant. When I say when two variables means, if I say case 1, when x is constant and y and z are the variables, it means what? It means dx value will also be constant, will also be what? 0, and dy and dz will exist. Clear? Small volume, small differential length in terms in y axis and small differential in z axis will be exist, but dx, if x is constant, dx will also be 0. In that case, surface vector or surface area will be formed what? Surface vector in the plane surface area कौन से plane में exist करेगा? YZ plane में. And in that case, differential surface vector will be equal to what? dy multiply में this dy into में dz. dy into में dz. Clear? Now the unit vector will be, as I have already told you, that if x is constant, yz, this is z, this is y, and this is x. If x is constant, then this type of plane surface area will be formed. Clear? In that case, unit vector will be what? Towards this outside the screen or inside the screen? That will plus minus में a cap x, means unit vector direction will be perpendicular to the plane surface area. Clear? So in that case, ds vector is equal to dy into dz a cap x. Clear? Now for the second case, if I say y is constant, x and z are the variables, then ds will be equal to, similarly will be equal to dx into dz into a cap y, and similarly dz multiply by dy. If I third case, when z is constant, y and z are the variables, in this case differential surface vector means, this one is the, if I say differential surface vector means smaller surface area of smallest cuboid or differential cuboid will be equal to what? dz into my dy multiply में a cap z, and this a cap z can be plus or minus, this a cap y can be plus or minus. Similarly, if I say whole cube volume is equal to what? Length multiply breadth into my height, similarly dv will be equal to what? dx into my dy into my dz, differential volume of a cuboid. So these are the three cases where differential volume surface area will be given normal. First one is when y and z are the variables. So this one is the, and this one is the unit vector direction plus k cap or minus a cap, that depends on the volume overall formed, which is inside or outside, and unit vector direction is always taken outside the volume. Oh sorry, it should not enclose the volume. Similarly, if x and z are the variables, this is the, and this one is the a cap y direction, or this one. Similarly, this one dx and dy into my a cap z. Now next one is the differential element in cylindrical coordinate system. If I say differential element in cylindrical coordinate system, you will see that in the cylindrical coordinate system, what y, sorry, if I take this is x, this is z, and this one is y. If I say this point P, which is having rho, phi and z, so you will see that this point P, let's say observe, this point P will pass through what? Okay, and if I take the transformation of P at this plane, this one is P, and you know that this one is the what? Rho, so you will see that this one is also this one is the rho. Clear? So you will see, and this one is what? Phi. This one will be phi. Clear? And this one is z. Now see, if I take differential element in cylindrical coordinate system, so you will see here that a small, let's say if I say small cylinder will be formed of this one. Clear? First consider, or first find out the differential displacement is given by, means this dl is given by what? This length, and the differential length is always calculated when two variables are constant and one is means this differential length is all, differential displacement is called when one coordinate point is variable and two coordinate points are constant. In that case, dl will be equal to what? Means if I say this dl will be equal to what? Differential length d rho into a cap rho. This is dl equal to d rho into a cap rho. Clear? Now plus, in that case, if I say differential height, this one is differential height, this differential height will be equal to what? This one direction, this is dz into my a cap z. If I say this blue portion is the differential surface area, differential volume of this hole. Clear? Let's say if this point P is this one, the smallest cuboid will also smallest circle will cylinder will also be formed like this one. Now if I say DL is in this direction, in case of phi, let's say this one is the phi in this figure, this one is the phi, but differential phi will be equal to what? This one, this will be what? Differential d phi. When d phi is to be determined in terms of displacement, this arc will be formed. You can also say that if this one is the figure, differential phi will also be that, like this one. Clear? So this phi differential length will be what? This one is arc is the what? Differential length when what? When when rho and z are the constant, phi is the variable. So this differential length will be what? Arc, and this arc is equal to what? Radius multiply में theta, and this theta is equal to d phi, and this radius is equal to rho into में d phi. So this one rho into में d phi, and direction of this arc will be in this direction, that is in this a cap phi. Whether it will be in this direction, you can say plus minus a cap phi, or this one. Now similarly, differential normal area, you can say it when two coordinate points, when one coordinate point is constant and two coordinate points are variables, then a surface area will be formed, and this surface area will be equal to what? When rho and phi are constant, when rho and phi are the constant, you will see that rho and phi are the variables and z is constant, then you will see that normal surface area will be what? When rho and phi are the variables. Now see, when z is constant, you can say this z is constant, and rho and phi are the variables, means this type of figure will be formed, this surface area, or you can say this bottom surface area will be formed when z is constant. When z is constant, then rho will be what? Differential length multiply में this one, and this one is what? D rho, and this differential length is equal to what? Rho into में d phi. This rho into में d phi into में dz equal to multiply में a cap z. Unit vector will be in this direction or in this direction, that is a cap z. Now second case, when rho and z is constant and phi is variable. When phi is variable, you will see that this phi is variable and what? Rho and z is the constant value. No, I have write down the opposite. This is not. Phi is constant and rho and z are the variables. When rho and z are the variables, and phi is constant, means this planar surface will be formed. This one or this one. Clear? So in that case, surface area will be equal to what? Will be equal to what? D rho into me dz into me a cap phi. Now, when third case, when z and phi are the variables and rho is constant, in that case this, when z and phi are the variables and rho is constant, in this one, this rho is constant at this point, this area will be there, or you can see this one back wala. Clear? So in that case, ds is equal to rho into my d phi into my dz into my a cap rho, and similarly volume will be equal to what? Rho into or multiply all these differential elements and differential length elements in respect to the in a cap a rho a phi, that is a rho multiply my rho into my d phi multiply my dz, that is rho d phi dz. Clear? Now similarly, if I say differential element in the spherical coordinate system, let's say this one is the whole sphere and this one is the smallest differential sphere. So differential sphere. So in that case, there will be 3 dimensions. This one is what? dr. This one is, you will say r into my d theta, and this one is this one, this area will be equal to r into my sin theta d phi. So differential displacement will be, as we know that the differential length is equal to dr a cap r into my d theta. I will tell you, this one is the rho d phi a cap phi. Clear? The r d theta is what? If I say this is point P, this is theta. If I say the differential length, differential d theta will be equal to what? This one, and this one is r. I will to, so d theta will be equal to what? This length will be equal to what? This dl in respect of this one, r into my d theta. This is equal to r into my d theta, that is equal to this differential length, that is r into my d theta a cap theta. Similarly, normal surface area will be there. That multiplication of these two will give you what? R into my dr d theta d phi a cap phi. Multiplication of these two will get, you will get what? This one, and multiplication of these two components will get this one. Similarly, differential volume is equal to multiply all these differential parameters, differential elements, you will get the volume of the whole sphere, that is r square sin theta dr d theta and d phi. So in the next lecture, we will discuss about the numerical related to the differential surface area or surface vector. The book, the content which I have provided in the slides has been referred from the Principle of Electromagnetics by Matthew N.O. Sadiku book, and thank you.